Hello everybody. Okay, so here's a problem that I want to look at, not so much because the calculus is difficult, but because of how much algebra is involved in simplifying to our final answer. Okay, so here it is. I want the derivative of this, 7x over 5x plus 9 all to the 6th power. And when I look at that, I see that there would be two rules involved in it. I would have to use the quotient rule at some point just for the inside function. I mean, if you had that all by itself, you'd have to use the quotient rule. So the quotient rule at some point will be in play here, but also because you have a function to a power, you have essentially a composition of functions, and you would use the chain rule. Okay. All right. So here goes. I'm thinking that because at some point the quotient rule will come into play, why not just get that out of the way first? Just seems like it would simplify the whole process if I did that separately. You could do it however you wanted to, but for showing you, I'm gonna find the derivative of that inside function 7x over 5x plus 9 all by itself. And by the quotient rule, here's what it would be. It's the derivative of the top function times the bottom one as it is minus the derivative of the bottom function times the top one as it is. That's one way that you could describe the quotient rule. So there's that, and once I get that, the rest of it's algebra. I would distribute the 7 and get like so. I would combine like terms and cancel and get this. Okay, so if at any point I need the quotient rule to find the overall derivative of this, there's the result. Okay, all right. So if I continue to part 2 and I say, okay, well, to find the derivative of that original function, 7x over 5x plus 9 to the 6th power, I would use the chain rule like this. I would bring this power to the front. I would take one away. And then what would go here is the derivative of whatever is inside this power. But I've already done that. Okay, so I'm using the chain rule plus the result from part 1. All right, so that's why I did it that way. Okay, now there you go. The calculus is over at this point. The rest of it is just more algebra. So there's a few things that I've done. First of all, this power applies to each part of that fraction. Exponents distribute over both multiplication and division. So I get the 7x gets the 5th power, the 5x plus 9 here gets the 5th power, and then beyond that I'm multiplying these fractions, which I do straight across. I got a 6 over a 1 times this over this and this over this, and collecting it all together into one fraction, I look at it like that. Additionally, I mentioned just a second ago, exponents distribute over both multiplication and division. So if I have 7 times x to the 5th power, that would be individually 7 to the 5th power times x to the 5th power. Then on top of that, I see that there's some arithmetic that can be done, like 7 times or 6 times 7 to the 5th power times 63. That turns out to be a little more than 6 million. Okay, so there's that number, and then x to the 5th power. And then on the bottom there, I'm multiplying like bases, so I can add their exponents together. 5 plus 2 is 7. Okay, so that's the whole process. Now, I mentioned a few things in here in passing that I want to talk about more detail, because I told you at the beginning here I wanted to do this question partially because of, at least partially because of how much algebra is involved. What about the way I treat these exponents here? I think that's an important part. So in my notes I said know your exponents, know your rules for exponents. Exponents distribute over both multiplication and division, and that's going to look like this in practice. A over b all to the n power is a to the n over b to the n. A times b all to the n power is a to the n power times b to the n power. For this, you notice we did have that right there. So that says, okay, both top and bottom get that power. Okay, looks like that. And then because that's 7 times x, each the 7 and the x get the power 5. Okay, so that's what I did. Exponents do not distribute over addition or subtraction, so I would not do anything further with 5x plus 9 to the 5th power. So that's how you came to see 7 5th power x 5th power 5x plus 9 5th power. Another thing is when you, I said at least in passing down here, when you multiply like bases, you add the exponents. That's how I get a power of 7 there. It looks like this if you put it in rule form. And indeed, like 5x plus 9 to the 5th power times 5x plus 9 squared, you're multiplying like bases. And when you do that, like if we take this as a general rule, I can add the powers, and that's how I get 5x plus 9 to the 7th. Okay, so in calculus, we might find that we have to learn more about algebra than we already knew, or at least get better at using some of the rules and recognizing when to use them. I hope this helps if you are having trouble with the algebra or the calculus. Otherwise, send questions my way.